Hi, my name is George Lamb, and I'm the VP of Customer Care here at Nextivity. What we want to talk about today is how you can use the QUATRA BOM estimator tool to help you figure out what you need to do as far as planning your QUATRA installation. So we're going to talk about how you use the tool and some other tips and tricks for planning your QUATRA installation so that your Cel-Fi QUATRA system works just as well as it possibly can. Of course, I'm not going to do this by myself. I'm going to have a lot of help. Almost all the help, as a matter of fact, from one of our solutions architects, Steve Van Skyke. So Steve, what I think I'll do is just hand it over to you, let you take it and run with it, and I will sit in the background and monitor the questions. I'll answer some of them online, and if there's something that I think everybody would benefit from, I might interrupt and ask you the question during the session. So take it away, Steve.
Hello, everybody. My name is Steve Van Skyke from Nextivity. I'm a solution architect. And I will walk you through the usage of, as George said, the QUATRA BOM estimator for estimating your bill of materials for a project. And then I'm going to throw in a few extra details to kind of showcase the end-to-end process. It's a very simple to use tool and a quick way to come up with your list of hardware that you may need for a proposal or something like that. And I think you'll find it to be very, very useful. You will find it at the bottom of the QUATRA product page on our Cel-Fi.com website. Just scroll all the way to the bottom and you'll find it. And shortly we will also be including this help material on the web page itself for the estimator. All right, the material that we will cover today, I'm going to start out with a site questionnaire, something that a lot of you are used to handing your customers because you need to get some details, of course, about the project at hand. And then visiting a site, right, because there's nothing better than being there and actually knocking on the walls to see if there are hollow walls or solid walls, seeing how they use the spaces, etc. Hopefully measuring the signal levels and looking for good donor antenna locations if you're going to use an off-air signal to feed the system. Then we will get into the estimator tool itself and determine how much equipment is most likely required for the site. It is an estimator. You can make some minor adjustments along the way, of course. Then we'll take a look at where the coverage units will most likely be placed within the building and adjust those placements depending on what the floor plan looks like and utilization within the building. And then we're going to spend a little bit of time on donor antenna placement. That's key to an off-air system, right? You want a good signal coming into the system in order to get a good signal being distributed within the building. And then a few other things such as splitting your donor antenna to feed multiple network units. Of course, you can do that. There's just a rule or two to keep in mind, but that will save you a lot of cable space in order to get down to where the network units are located. And then we're going to go over a bunch of examples because seeing just helps drive it home. There's a lot of power that comes out of our coverage units. The power density is high, which means using less equipment. And it's good to see some of this in practice. We also are in the IBWave catalog, and the VEX files and other information is also available on that product web page down at the bottom of the page. And we found that it's a good idea to do the BOM estimator tool even when you're doing IBWave and make sure the two are roughly correlated. Like any other tool, it's as good as the person who's using it, and our systems being a bit higher powered and the fact that we have full power at our coverage units, that's a little bit different than putting in a DAS. We don't want to see people put in too much equipment, actually. That just drives the price up per square foot, and that's not what we're here to do. So we'll talk about that as well when we do our examples. All right, so the very first thing I'll talk about is a questionnaire. And this is getting in touch with the customer and just trying to get a feel for the site, generally over email. You can have them send you floor plans. I like to look at the site on Google Earth because it tells me something about the building, right? If it's an old building like the one you see in this picture, it's probably got more difficult concrete walls inside to get through. If it looks like it's a stand-up building with exterior walls that are solid, but the interior tends to be open, that's much easier to cover. How many floors are in the building? What's the shape of the building? Again, the floor plans, you'll want to request those. And you might want to, if you're certain that you're going to get the bid, you might want to start the discussion about having an internet connection for the system. You need the internet connection in order to commission the system on site, but it's also a super handy thing to have long term, because if you ever need to revisit the site because the customer has a problem, you can do it from the comfort of your beach chair, right? You don't have to go to the site in order to see how well the system is doing. And that can be a great time savings down the road. And then also, of course, asking them where the IT closets are. Equipment tends to go into IT closets, and you'll want to know, obviously, where they're going to allow antennas on the roof, etc. Then the actual site survey. Again, I think it's really important to go take measurements at a site to understand exactly what you're trying to solve. If it is a location that is void of signal and you're really just providing coverage, then with any solution, you're going to get a greater reach from your service antennas or coverage units, and very good reach from a Quatra system. If you have a lot of interference coming in from outside, then you may want to think about adding a little bit of equipment, because you need to dominate over that interference. So I really like to walk around a site with phones from the different operators. Obviously, if you're fancy and you have a pilot scanner or other things, you may be taking a little bit more detailed information using more expensive equipment, but you really don't have to. I like taking pictures to know how they're using their site, right? Do they have, if it's a warehouse, it could be wide open, like a shipping receiving area, or it could have merchandise stacked to the roof of the warehouse. It's going to be hard to get through. So usage is really important. And then I'll take those floor plans and write information down on those floor plans, knock on the walls, and really get a good feeling for whether they are hollow walled or solid walled, or anything else I might want to learn about that site. And of course, you're looking for penetration, allowance to the roof, and asking the customer about how comfortable they are having equipment being visible, or do they want to hide things, etc. Now, on to the estimator tool itself. Again, it's very, very simple. In this example, we have a floor plan, and the idea is to break up the usage of the floor plan into 4 different types of spaces, from the wide open area, such as a warehouse or a parking structure, to the typical cubicle land. How much space is allocated to more of those open plan office spaces, or hollow walled offices, very common in most buildings, or the worst case scenario, which would be the solid walls, right? Very, very hard to get through. But you're trying to get an estimate of what percentage of the area of the total project is allocated to these 4 different area types. Now, how can we do this? One thing to remember, and you guys that are used to using IBWave, within IBWave, we are modeled as a small cell. Why are we modeled as a small cell? We're modeled that way because we know our output power. We are a lossless system, not a lossy system of cables, splitters, and taps, which means you don't have to do the calculations to figure out what your resultant output power might be from a service antenna. And that gets further complicated because you're not even sure what the input power level, the donor signal level is of these different operators for a passive DAS system, because it has to apply the same gain to each one of those channels within a band. Remember, Cel-Fi systems are different. We assign individual radio chains to every channel, which means we can apply more gain to a channel that comes in as a donor that is of lower power. We want to normalize everything to full power at our output. That makes planning simple. I know what my coverage is, or have an extremely good idea of what my coverage footprint is from every coverage unit. So again, back to this example here, we have come up with some numbers. There are no wide open spaces on this one, but we are estimating about 45% cubicle and about 50% hollow walled spaces, and 5% to those stairwells that, if you like to cover those are typically wrapped in concrete, right? Then again, the QUATRA BOM estimator is at the bottom of the product page on our website. Click on it, this page will open, and it's a very easy form to fill out. You're going to choose square feet or square meters. Then you will put in the project size. Now this is the project size for the entire project, not just one floor. Although, of course, you can break a project into smaller projects if you have multiple buildings or for some reason you're feeling more comfortable doing that. But otherwise, just put in the total square footage, and then you will select the donor signal type. This can be small cell, internal antenna, or external antenna. If somebody puts an uses internal antenna mode on a network unit, we're going to assume that you're going to have some feedback issues that will cause the system automatically lower its gain. So you'll probably get a smaller footprint. But that's a guess, right? Remember, this tool is an estimator, so it takes a number of things into account. But for most of you, you will use either small cell or external antenna. And assumptions that this tool makes: it assumes that you have perfect isolation between your coverage units and your network unit or the donor antenna source, which means full power. Why do we assume that? We assume that because you can use our portal to see if you actually have a feedback problem. If you do, the system will never oscillate. It always protects the operator's network, but it will reduce gain to prevent any feedback from occurring. But you can tell from the portal that you have feedback. Go fix that issue by, say, moving a coverage unit to the other side of a metal structure or something for the coverage unit that was the problem. Get your gain up to full power where it should be, and then the estimator tool should mirror what the tool is trying to get you to achieve. Once you have done that, you can see that you will put in your percentage for those 4 spaces. Here we have the 0% allocated to an open space, 45% for cubicle, 50% hollow wall, and just 5% for solid wall. And then you will press calculate. You'll immediately be presented with a screen that is basically your laundry list of the hardware that you need. Now, you can email this to anybody you'd like. You can give the project a name so you can keep them organized. And keep in mind that this tool tells you basically how many coverage unit locations you're going to have. And I'll show you what that means in a minute. Let's say, remember, we have many different kinds of Quatras. We have the Quatra 1000, of which we have, I think, 6 versions currently around the world to cover the different bands for different operators in different regions. And then we have the Quatra 2000 here in the United States that is a dual operator system. If you wanted to supply a system for all 4 operators within the building, you would use 2 Quatra 2000s in parallel, which means that if this tool says 3 coverage units, but you're going to be using a 2000 and you want to put in 2 systems in parallel, you're actually going to use 6. And I'll show you some examples of that. But either way, this gives you an idea of your coverage, how many coverage unit locations need to have equipment. Of course, the more open the area, the larger coverage footprint you're going to get. And the circles that are drawn on this map, of course, it's not going to be perfect because in real life things are never going to be perfect, as in a circle and all that. But these are actually the coverage radiuses that the tool uses. It does count for overlap. It does use indoor propagation modeling in order to come up with these numbers. But let's say for this example, you were told to put in 3 coverage units. You can literally start by spacing out the 3 coverage units in a fairly uniform fashion, especially for this building because it's somewhat similar between the different areas. There's not too much of a difference between the hollow-walled spaces and the cubicle spaces within these buildings. So I would just put the coverage units rather uniformly. But then after that, you want to take advantage of the fact that your RF propagation will improve in open spaces, right? So you want to start moving these coverage units around a little bit to take advantage of hallways or dense areas that you feel you need to put a coverage unit closer to, or maybe the customer has said, I really need to make sure these 2 areas are covered really well, where our C-class employee suites are, or maybe the cafeteria. Can you really make sure those get some preferential treatment? Then maybe you want to move your coverage units a little closer to those areas, which is what I've done here in this drawing. The left side coverage unit was moved closer to the denser area to be covered, but still placed out in the open between these different office spaces. And the same thing was done on the coverage unit that was on the right. And the coverage unit that's in the center here, we moved up a little bit in this drawing to put it in that hallway, right? That way, this would have no problem covering all of those cubicle spaces, but it's also nudged towards those office spaces that are on the north center side of this building. And now basically you have your plan, right? This is a pretty good plan of how many coverage unit locations you need to put equipment in and where those coverage units should go. Now, as I said before, if you are putting in multiple systems, and remember, a solution for Quatra doesn't just have to be one Quatra model type, 1000 or 2000. It could be a complete mix. You could have 2 different 1000s for different operators, or you could have Quatra 2000s and put 2 of them if you're in the US to cover the 4 major operators. And that's exactly what this slide is showing. You'll notice that we simply doubled up on the hardware because these 2 systems go in parallel, but the locations are of course the same. And remember, this is a digital system, and Cat5e LAN cabling is dirt cheap. We don't care if that cable's a foot long or 650 feet long. You're going to get the same full output power from it, which means if you're not sure where a coverage unit's going to go, then just leave some extra cable coiled up above the ceiling tiles. And that'll give you some flexibility on moving things later.
Can I really go 650 feet on a single Cat5 cable?
We have, you can, just like other Ethernet equipment, we all use the same Ethernet drivers, if you will. It's 100 meters point to point, and that's why in a building you'll see MDF and IDF closets are really cabled about no longer than 100 meters. That's about 325 feet. We allow one range extender, which is a Quatra purpose-built device, which lets you double that distance and get out to 650 feet, 200 meters. And
can I use some of the Ethernet range extenders I already own?
No, they will not understand Quatra signaling. It's a great question. You must use ours, and you can use 1 per line. Now, the larger the building, the more Quatra systems you'll put in. And if you have a project that's so large that 650 feet, you are exceeding that distance to get out to a coverage unit, you're going to end up with another cluster of systems over in that part of the building. But that would be a very, very large project. But again, the larger the project, just use more systems. Now, remember, I wanted to talk about donor signals, because if you are, obviously if you're connected to a small cell, you don't have to worry about that because you own the source. But if you're taking your signal off air from the outside, then you want the best donor signal that you can possibly get. And one of the worst things you can do is use a meter that just tells you RSSI, because RSSI meters are important with a lot of BDAs because you need a lot of input power because their gain is limited and you're trying to get to maximum output power. But with a Quatra system with 100 dB of gain, gain is much less. I'm sorry, gain's important, but the strength of your donor signal is much, much less important, because we'll just apply gain individually to those channels that are being relayed in order to get them to max power at our coverage units, which means that I care more about the signal quality, right? A lot of phones these days do not just show you a number of bars based on the signal power that you're receiving from the operator's network. They actually take signal quality into account. So if you want more bars of signal to show up on your customers' phones, then you want to bring in a better quality signal. How do you do that? Well, you've got to take some measurements in order to choose your donor antenna location intelligently. Speed tests are great because they sort of take everything into account, but do a number of speed tests in order to get a feel for what is actually coming from the macro network, because it's going to go up and down with loading over time. And you always want to test during the normal operating business hours for your customer, right? Because that's when the donor signal will mean the most. In this slide, you might be on top of the building, or you may only be able to get to the upper floors of the building, but that's okay. Go to the center of each side of the building and do speed tests from a window. You're literally using the mass of the building to block signals coming in from other directions. And this will help you get a feel for what direction, what side of the building you should put your donor antenna on. We'll do fine tuning later, but you need to start out in the right spot, right? So you can either do speed tests, or we'll get into the actual signal quality metrics in a minute. If you're familiar with signal to noise ratio, RSRQ, etc., then there's, of course, you can use fancy equipment or even some smartphone apps in order to determine those metrics. These are the metrics that we just talked about. Went ahead and included a slide on those for 3G and 4G, so you'll have an understanding of what is a good signal from a quality perspective and what is a bad signal from a quality perspective. So this is a handy resource to have when you're doing these exercises. Donor antenna options, very important. We have a panel directed antenna. Why did we go with a panel? It actually has very, very good performance, but panels are easier to stealth, if you will, than a Yagi. We also have a dual feed omnidirectional antenna. If you're using a Quatra 1000, you're always going to want to use a panel antenna and point it at your operator's tower. And you can also use that antenna for, of course, a Quatra 2000. Any place where you want to try to clean up the signal to noise ratio, go with a panel antenna. You're not so much using it for gain. In general, you're really using it as a filter, because you want to reject signals coming from unwanted towers that are actually interfering and causing your signal to noise ratio and your capacity to drop. The omnidirectional antenna is useful if you have good signal quality from all the operators that you want to relay. You don't have to aim it. It's simple. You put it on the roof. Whatever your experience is outside, you're bringing indoors. And that's just a simplified approach. But again, if you have a signal to noise problem, then I would definitely go with the a directed antenna to clean up your signal to noise ratio. Splitting antenna feeds to feed multiple network units. You can split it as many times as you want, but the metric here is try to hit your network unit at minus 90 dBm RSRP for LTE. We will operate far below that. But what you don't want to do is have so much loss in your donor antenna feed and its splitters that you're robbing yourself of uplink power. LTE likes a lot of uplink power, so that isn't something that's going to be healthy for your uplink. A lot of people concentrate on downlink data rates, but uplink's very important also, especially for making calls and things like that. So if you utilize this technique, then, and I'm sure all of you will, just take your measurements from the roof where your donor antenna is going to be. Let's say I had a donor signal level, RSRP pilot level for LTE of minus 90 dBm on the roof using a phone. Now, a phone typically has an antenna of 0 to minus 2 dBi, but you're going to put a high gain antenna up there, right? Let's say it has 10 dBi of gain. Well, that means if my phone saw minus 90 dBm RSRP, I should be seeing minus 80 dBm RSRP through this antenna. That gives me 10 dB of room to play in order to get from that donor antenna down to the network units. So I can split it. In this case, we have, let's say you had a four-way splitter, you'd be looking at 6 dB down plus your cable loss. You can figure that out in order to make sure you hit your network units at minus 90 dBm. And help ensure the uplink. And again, it doesn't mean it's not going to work if you go below that. We're just trying to make sure that we go for performance here, and we'd like to close the uplink the best we can during these installs. So this is the guide you'll use to make sure that you don't have too much loss in your donor antenna. When measuring, people have fancy tools, etc. Remember I talked about not using RSSI, because RSSI, you can have a stronger signal because you have interfering cell sites. All of that energy gets amassed together, and your RSSI meter shows, hey, you've got lots of donor signal. But it doesn't tell you that it's actually completely pilot polluted and has massive capacity issues, etc. So RSSI meters don't tell you what you need to know unless you have a low gain system where you need all the input power you can get. It's better to understand your signal level and quality metrics. We decode that naturally, so on the portal we're going to show you that information, but if you're walking around during a survey, I like to use this app called Network Cell Info Lite. There's plenty of other ones out there. It must be an Android phone. Don't use an iPhone because they don't have that information available to applications the way that you can get them as in Android. And if you look at the screen here, you'll see I have the pilot level of minus 113 here. And remember, the pilot level for LTE is a very, very low level. It's the pilot energy for a single carrier, a single subcarrier, so it's very low. The bottom end is south of minus 120 dBm. And we have, it's labeled RSSNR here, but it's really the signal-to-noise ratio here is minus 2.2. Anything south of 0 dB is not a good donor signal. You can make a call down to, say, minus 6 or so, but you really want to bring in a lot more than that because you have a lot of handsets you're trying to feed within the building. We want to clean that up. RSRQ, again, around minus 120 is the bottom of the barrel. We would like to have that much, much higher than that. And I take a piece of paper with the floor plan, walk around the building, and just write these 3 numbers down for the channels that the phone tends to go to as I walk around the building.
Just making sure, you said minus 120, but you meant minus 120 is the bottom of the barrel, right?
Minus
20 is the bottom of the barrel.
Well, minus 20 RSRQ, yeah, and minus 120 RSRP. And okay, you can go below that on pilot level, but at that point you're relaying noise, so it's not as healthy for the network. All right, but this is taking information about the building and to try to understand what you're going to be utilizing. When does that become important? If you're walking around a building and it's a place you're going to provide service and you see an RSRP level of minus 80, then it has a massive pilot pollution problem. And you're going to need to put in more equipment no matter what solution you use in order to overcome that problem, right? But that's where getting that information up front when you walk around the building makes a lot of sense. I've seen installations where people have, where they've had extremely low levels of existing signal within a building. Let's say it's a big metal warehouse. And when you're not fighting against interference from the outside, you can stretch your budget. You can put in less equipment and easily cover that kind of a building with less equipment. So again, I promised you that I would give you some examples so you'd have a bit of a visual on the amount of equipment that goes into a project. Again, the most important thing that comes out of the Quattro BOM estimator is the number of coverage units, because that's what really determines how many networks you're going to have, maybe how many antennas you'll use, etc. In this location, it's a typical high-rise building with a central concrete core. Of course, very, very difficult to get penetration into that core, so you need to surround it with emitters. In this case, we're using a single Quattro. Maybe they only want to boost 1 operator, and I just needed to find a place to put those 3 coverage units. And I've spaced them out to take advantage, again, of hallways and open spaces. If this had been a Quattro 2000 and I only wanted to boost 2 operators, then I would have used a Quattro 2000, but the layout would have been exactly the same. Now, if I wanted to go to multiple systems, maybe you had multiple Quattro 1000s or multiple Quattro 2000s, then you're going to double up, you're going to increase the level of equipment. It's still 3 coverage unit locations, but in this case, I'm using a Quattro 2000. Each one's doing 2 operators to get a total of 4 operators, and the coverage unit locations are the same. And these coverage units are going to go in the ceiling a couple feet apart. Just a ceiling tile apart is fine. But you get the idea for using the tool but actually needing double the equipment. Here's another example, and it's easy to see. I like this one because it's a nice large space, but it has a lot of open spaces. So you get a feel for, again, putting those coverage units where their signal can propagate as far as possible before being attenuated by structures. There's a higher concentration of them over in the areas where there are more walls, but definitely places were chosen where a coverage unit has direct visibility into these larger areas as well. In this case, this is another high-rise. We could have done this with just 4 coverage units, but a 5th one was put in the center of the building in the elevator lobby on purpose. Probably didn't need to put one in every single elevator lobby, but as some of you know, it's difficult to get equipment in an elevator lobby due to codes and other regulations. But if you can put something in the lobby and hopefully it will get into the elevator shafts, and maybe you do that on every 3rd floor or something like that, but that's why there's a coverage unit on the floor of this lobby. This is a school. And the coverage units were placed, again, to take advantage of open spaces and hallway crosshairs, right? So that way the coverage units are, they're going to light up the halls like crazy, but of course we want to get into make efficient use of our coverage unit placement to get into the classrooms, right? I wouldn't have put a coverage unit in the classroom. I'd rather have it in the hallway where it can see as many classrooms as possible. Now, this example, we're showing 2 floors on purpose. I haven't been to a site yet where I haven't been able to get penetration from one floor to another. Remember, our output power density is high. So when I do a test with a coverage unit, sometimes we do preliminary testing at a site because the customer wants to see exactly what propagation was like in their building. And they may even want to use that information to calibrate an IB wave project that they're doing. I like to alternate the placement of the coverage units between the different floors because I know that from my experience, I'm going to get coverage above and below. I can use this technique to install less equipment or use this technique to install the same equipment but get a little bit of added benefit from alternating the coverage unit placement from floor to floor, odd and even floors. All right, just getting back to the basics of this presentation, the summary, knowing your building size, of course, up front so that you can start using the tool, getting a floor plan from your customer so that you can estimate using the Quatra BOM estimator where how many coverage units you're going to need and what based on what the wall types are and what the area types are, and then placing those coverage units on the floor plan and maybe moving them around depending on hallway and open space options that you may have. And then, of course, you will know at that point, you may have to adjust your plan because of the number of floors or odd shapes of a building. Remember, the estimator doesn't have a clue what the shape of your building is, right? If it's long and narrow, then you may need to add a coverage unit or 2 in order to cover that space. Or if you have a high level of outside interference, you may need a little bit more equipment in order to dominate over that interference. So start with the tool as an estimator, and then use that information that you have from the site and the floor plan to make minor adjustments on how much equipment you're going to have. And then you've been able to come up with a plan, hopefully very quickly, with minimal effort to have a good baseline on what you need to do on a specific project because every building is different. All right, that's the end of the presentation. If George finds any questions, or of course you can always come and ask us. Our support department's here to help you. And this presentation will be on the Quatra BOM estimator page very shortly.
Not a single question, Steve, so you must have done a great job. I guess we'll wrap this up. Thank everybody for attending. And again, look for this webinar and future webinars to be on our website, streaming on demand. Thanks so much. Bye-bye.
Thank you.